All right, now we're going to spend some time talking about the different kinds of chemical reactions. And the first kind of chemical reaction that we're going to talk about is precipitation reactions. Now, precipitation reaction is one uh, in which dissolved substances react to form one or more solid products, okay? Now, they could be dissolved in whatever, okay? But here's the important point. You produce a solid product when there was no solid product in the beginning, okay? So these are also known as double displacement, double replacement, metathesis reactions. We're going to call it precipitation reactions, all right? So many reactions of this type involve the exchange of ions between ionic compounds in aqueous solutions. So the most common ones we're going to talk about are ones that are dissolved in water. Precipitation reactions are common in nature and industry, and they are going to be set against the backdrop of something called solubility. Solubility is the maximum concentration of a substance that can be achieved under specific conditions. That is, how soluble is something? That's the maximum concentration of a substance that can be achieved under specific conditions. Okay. Substances that have a relatively large solubility, if it's a lot, then we say it's soluble. If it's not a lot, we say it's insoluble. And it turns out there's really a huge bin of products that we're going to call soluble and a huge bin that we're going to call insoluble. So don't worry so much about what means large and what means not large or what means small. Now, if a substance comes into a solution where it's the maximum concentrations are exceeded, in other words, we have too much, then we're going to get a precipitate. Okay? And a substance will precipitate when solution conditions are such that the concentration exceeds its solubility. Substances that have a relatively low solubility, as I already said, are we going to call insoluble. And again, don't worry right now about what means low and what means large. Large and low or small, don't worry about that. Mostly we're going to memorize what is soluble and what is not soluble, okay? So here's a chart. Every textbook has a chart that looks like this, and this is really helpful, but you've got to get your eyes used to it. So first of all, soluble compounds contain, watch this, group 1 metal cations, and that would be like sodium, potassium, okay? Group 1 metal cations, and also the ammonium cation, right? NH4+. So these are soluble, like so if you see something, sodium nitrate, you know it's soluble because it has sodium in it, all right? They also have the halide ions, like chloride. So if you see something that's chloride, it's soluble. And they also have acetate, bicarbonate, nitrate, and chlorate ions, right? Where chlorate is ClO3 minus, okay? And the sulfate ions. So you have to memorize these. Now, notable exceptions are the halides of silver, mercury 1, and lead 2, right? For example, silver chloride is not soluble. It's going to make a solid. If you put sodium, we already saw that in a previous conversation, right? Or mercury 1, chloride, right? That's going to precipitate. I'm saying mercury 1. You see the 2 right there? That's because where that name comes from, we have that in a previous conversation. This, it turns out, is mercury 1. All right, so insoluble compounds are the hydroxides. If you see a hydroxide, you can generally say that's insoluble, right? Now, sodium hydroxide is soluble because it's an exception. It's a group 1 metal cation, or ammonium hydroxide would be soluble, but generally speaking, if we see hydroxide, then it's going to be insoluble. Carbonates are generally insoluble. Chromate is generally insoluble. Phosphate and sulfide, okay? So this table, the only way to get this, I would not memorize this without doing a great deal of practice, right? So we're going to go to a particular practice question here. And you see, first of all, since it's aqueous, you know that the halides are soluble and the group 1 metal cations are soluble, right? Lead is generally insoluble except when it's with nitrate, right? Let's go back here to the previous slide. So nitrates, insoluble exceptions, actually that doesn't show it here, but we know that, look at this. Yeah, we know it's soluble, right? Because, yeah, it does say. It's soluble because it's a nitrate, right? And there's no insoluble exceptions over here, right? Here's lead, but that's with the halide, right? You see that? Okay. So again, lead nitrate is soluble, okay? Now, the halide of lead 2 is insoluble, so it precipitates. Aha! That's where it is right there, okay? So lead 2 iodine, or iodide, pardon me, precipitates from solution, which is consistent with the solubility rules. The net ionic equation, you can see since this is aqueous here, potassium is aqueous over here, and it's aqueous over here, potassium crosses off, right? Since nitrate is aqueous over here and over here, it crosses off. So the net ionic equation is as so. All right, so here's an example of that. A precipitate of lead 2 iodide forms when you have lead nitrate and iodide mixed, okay? And so here's another example, sodium chloride. We saw this earlier. Sodium chloride, sodium is aqueous, chloride is aqueous, silver is aqueous, nitrate is aqueous, but when silver and nitrate see each other, when silver and chloride see each other, they precipitate, right? Why? Let me go back to that table again. This table is a little bit boogered up now because I've been drawing on it, but an insoluble exception of this rule over here is halides of silver. They will precipitate, and that's what we get right here. Silver chloride precipitates, and that's what we get. And the net ionic equation then is going to be like so. All right, so that's an example, or I should say rather, that's a brief introduction to precipitation reactions. The next group of reactions we'll talk about is acid-base.